Hello and welcome to Bad Astra. Today we will be interviewing Dr. Maria Weber, an assistant professor of physics at Delta State University and director of the Wiley Planetarium. Her research focuses on stellar magnetohydrodynamics, magnetic flux emergence, solar physics, stellar dynamo theory, fundamental stellar fluid dynamics, sunspots and star spots, M dwarfs, numerical simulations, and physics and astronomy education research. Hi, we're going to be talking to Maria Weber. She studies the sun.
Yes.
Hi, Maria. Thank you so much for joining us.
I am so excited to be joining you. This is a really excellent thing for me.
It's good to see you again, too. Over Zoom, I guess. That's how all communication happens now.
Yes.
So you use computer simulations to understand how the sun builds its magnetic fields. You're interested in sunspots and magnetic arches, and I understand they are gorgeous. And you're trying to kind of model the inside of the sun. So could you potentially use your simulations to determine, I don't know, the sun's favorite band or color or ice cream flavor, or whether the sun is busy next Saturday at 4 p.m., hypothetically, of course?
Well, I think that probably we can't determine things like the sun's favorite band, its favorite color. But it's interesting that you asked about what the sun might be doing Saturday at 4 p.m., for example, because one really important part of solar physics that we're trying to get better at is to predict the sun and figure out what it is going to be doing in the future. It's really hard to predict the sun. A lot of work has been going into that process. Part of my work is just a little tiny piece in that puzzle of being able to predict the sun. We're a little bit better at predicting its short-term behavior than its long-term behavior. For example, 11 years or so, which is the length of a solar cycle, is really hard to predict.
Short term is a matter of days or weeks, and long term is 11 years.
Yes, and maybe even longer, 22 years, which includes the sun's entire reversal of its magnetic field as well. You have this 11-year sunspot cycle where sunspots on the sun pop up over the course, they increase and decrease in number over the course of 11 years, but then the magnetic field also flips, like the magnetic field of a bar magnet flips during that time too. So you get 22 years between the reversals of the magnetic field to get back to like North Pole up again, for example, if you're thinking about a bar magnet inside there. But yeah, so short term would be a couple of hours. There are people whose job it is to sit and watch the sun, to make solar forecasts. It takes light 8 minutes to get from the sun to the earth. So 8 minutes later, we can see the light from the sun, so we can see what it's doing, but it takes a few hours to a few days for the energetic particles and magnetic fields to reach the earth. So you can see what's happening and you can plug it into some computer simulations in order to kind of predict, are those coronal mass ejections, solar flares going to hit?
What would be something about the sun that would surprise most people? I think most people consider themselves decently familiar with the sun. You see it every day. I mean, except finals week when you're stuck inside the whole
Yes.
But for the most part, most humans with like happy outside lives, I don't know what that's like, but I assume, see the sun every day and consider themselves to know a bit about it. What is something about the sun that would surprise most people?
Well, I think most people don't know that the sun has spots on it, the sunspots that I study, because you can't really see those sunspots from the earth with your naked eye. And actually, you should never look at the sun with your naked eye. Just don't do it. But for me, what I think is interesting is that we don't know what the sun's north and south poles actually look like. So we see the sun, just as, with telescopes, we can see, it as sort of the round sphere. But we haven't had any telescopes that have really gone over the north and south poles of the sun to image what's at the north and south poles of the sun. We know what the north and south pole of our Earth looks like and all the other planets. Jupiter has some really cool swirling hurricanes at its poles. Saturn has this awesome hexagon at its north pole. There might be interesting things. We think there's interesting things going on at the sun's north and south poles, in particular with its magnetic field. And that will help us be able to better predict and understand the sun's magnetic cycle. So we don't know what the sun's poles look like. So maybe someday we will have some telescopes that will sweep over the north and south poles to get images of what's there. We hope there's something cool and interesting, like some swirling vortices, swirling hurricane type things, but we never know. It might be really just boring. But in any case, even if the sun's poles are boring, that's still interesting.
I mean, I don't think anything about the sun could ever be boring. You're telling me that there are people whose jobs it is to just stare at the sun, and frankly, I think I made the wrong career choice. We should get on launching a telescope to do a sweep of the sun's north and south poles because, for science reasons.
Absolutely. Yes. That would be an excellent thing that we hope NASA would support.
Yeah. We could also just send the sun a text message. Maybe it'll send us a pic.
Oh, we could try that. That would be interesting research.
Yeah. And if you have the sun's number, obviously we can't tell everybody that, you could give it to me. I would be responsible with the sun's number.
All right. I'll hook you up afterwards.
Thank you. So back in 2019, you gave a TED talk about the sun, and you talked about solar storms. I'm going to play a little clip from that I found a little interesting, and I'm going to have to ask you some questions about it.
Right.
We find giant arches of hot, glowing gas extended above the sun's surface. This hot gas is stuck along loops of magnetic field attached to the sun's surface exactly within the sunspots themselves. On occasion, these magnetic loops become twisted and stretch so strongly that they snap like rubber bands and break off from the sun. These solar storms send tangled clouds of magnetic field and hot solar particles into space in massive explosions, with energies equivalent to millions of hydrogen bombs going off at one time.
My question is, why are you fear-mongering about the sun? Everyone has issues, and anger management is something we can all work on.
Well, it's a really important thing to be prepared for. I don't know if you've ever watched any of these like doomsday scenarios, but a lot of them do involve solar flares, coronal mass ejections, slamming into Earth. Now, it is a big deal if that were to happen. I mean, it's fairly rare that it would happen, but there was one that happened in the 1800s that a coronal mass ejection that struck the Earth, and it set telegraph wires on fire.
One solar storm in 1989 was so powerful that it caused a power failure across the province of Quebec, Canada, for 9 hours. In 2012, one of the strongest solar storms ever recorded narrowly missed hitting our planet. Imagine a world without GPS, an entire continent without electricity, hours and even days without internet.
In our technological world, so much relies on our power grid being functional. If one of these coronal mass ejections strikes the Earth in the particular place on the Earth that are susceptible to these coronal mass ejections, you can wipe out a power grid. You can be without power for hours or days, depending on how well your region is set up to respond to these types of situations. So it is kind of a scary thing, but luckily governments are starting to understand that this is an important thing just to think about. There has been some legislation in Congress to put in motion some funding to help support fixing infrastructure and learning more science in order to, sort of mitigate these types of situations. But it is a big deal.
On this channel, we actually did a video all about the potential of a solar storm. I'll put up a thumbnail. The video is, of course, what happens if Betelgeuse explodes. And it's all about sun solar storms, because we're really, really good at organization on this channel. What would your recommendations be for ways to mitigate that threat? Because it is actually serious. Like, sometimes the sun's love is just a little too powerful. It could feasibly take out most of the things we rely on day to day: GPS, power grids, communication networks. It's legitimately terrifying. What would your recommendation be for avoiding that?
I don't think it's entirely clear. I think they're trying to learn to figure out what to do.
Yeah, I mean, would radiation shielding help at all? Maybe, I don't know.
A lot of it is going to be the interaction of the magnetic fields coming from the coronal mass ejection with the magnetic field of Earth. And that causes what you call a geomagnetic storm. And those fluctuations of the magnetic field impact the electricity that's running through the power lines. And so when you're thinking about power, that's what's really going on there. And also, there are parts of the Earth where the rock, the crust that you're sitting on, is more susceptible to fluctuations in magnetic field, which can set up currents inside the crust there. So depending on where you're located on the globe, there are different parts of the rock that you're sitting on that are more susceptible to these impacts from coronal mass ejections than other places. So for example, the CME that struck Quebec is very susceptible to those types of interactions.
What I heard from that is that the way a coronal mass ejection or a solar storm can really impact Earth isn't that a bunch of particles from the sun are coming and hitting all of our stuff. It's that the magnetic fields coming from the sun interact with our Earth's magnetic fields, and that's what disrupts electronics.
Exactly. For the strength of coronal mass ejections that we usually get at the Earth, it's more so the concern is how it's going to impact our electrical grid. The energetic particles in particular are a huge concern for astronauts. They can get radiation poisoning if they're not shielded.
Doesn't the atmosphere and the Van Allen belts help protect us from?
Yeah, energetic particles are attracted to magnetic field lines. And so a lot of those particles funnel along the field lines of the Earth. They interact with the Earth's upper atmosphere. Those field lines are attached at the North and South Pole. That's how you can get the beautiful aurora. So if there's a solar storm, you also get the beautiful aurora effect. So in destruction, there is also some beauty.
Even when the sun is angry.
Yes.
So also in your TED Talk, you call the sun average, and you're mainly talking in terms of size.
In the grand scheme of our galaxy, our sun is actually a relatively average, unremarkable star.
Quite frankly, on this channel, we will not tolerate such slander. Who calls the sun average? Is the sun not the giver of energy needed for all life on Earth to flourish? Is the sun not the hottest body in our solar system? Do we not need to literally shield ourselves from its glorious rays lest we get burned? Shakespeare professed love by comparing the object of his affection to a summer's day. The sun is that hot summer's day.
I agree with you. The thing that I always think about is that the sun is ours, right? Without the sun, we wouldn't be here. So it's so important to us.
But we live with this star, and it is our personal and global connections with the sun that make it so important to us. We all have a unique relationship with the sun.
It is the most important star for us, but you got to think about the grand picture of the universe. Okay, the sun is only one of billions and billions of stars, like Carl Sagan says. So, and in the grand scheme of things, our sun is actually kind of boring. Okay. And maybe because it's a little bit boring, means that we can exist around the star. There are many, many stars out there that are way more magnetically active. So they're spitting off more of those coronal mass ejections and flares. And that would make it really hard to be habitable on that planet. So maybe because the sun is a little bit average and a little bit quieter than some other stars out there, that maybe lets us habitate here a little bit better.
So we've had a good 5 billion years, and yes, there are other stars in the sky, but the sun is the stable love we've gotten to know over the last 5 billion years as Earth. And, you know, there are some crazies out there. There are ones with magnetic anger management issues way worse than the sun. And really, we should be lucky to have the sun and know how lucky we are.
Yeah, I totally agree with you. That is exactly what a lot of astronomers or astrophysicists will talk about, and astrobiologists. Most stars in our galaxy are actually a little bit smaller than the sun, but the stars can get up to be about 100 times the size of our sun as well. So we're, I mean, if you like set up a number line of the sizes for stars, we tend to be more closer to the middle.
You know what? That's okay. I've always been of the opinion that size doesn't matter as much as what you do with it.
Exactly.
So for everyone who wants to see the rest of Dr. Weber's TED Talk, I will link it in the description. I highly recommend it. You learn a lot of cool, fun facts about the sun in a very short amount of time.
I make my students watch it. That's their first assignment, is to watch my TED Talk, so they learn what I do.
In addition to your job as a professor, where you make your students watch your TED Talk, you are the director of the Wiley Planetarium. So I guess my first question is, what does a planetarium director do?
I do everything. I am a staff of one. I run the shows, I coordinate the shows, I develop some of the shows, and decide what's interesting. We have public programming. I get to create programs to invite our public through, our local community and local school districts to come through to learn about space. It's so exciting. I get to do everything, because since it's just me, I guess I'm involved in everything from like fixing the hardware when the planetarium computers break, to because that happens, to coding up some of the shows so that I can create shows for people to watch, to all of the PR and management and financial stuff that goes into it. I get to see every aspect of it, which is a lot of work, but it's cool because at most big planetariums, you have a whole department that's doing each little bit of that.
Yeah.
And when you're at smaller planetariums, you have to do it all. So you have to learn how, and I didn't, you know, to be honest with you, I'm learning a lot of this as I go. I came in with science communication and a love of astronomy, love of space, but I didn't know a whole lot about some of those other things. So that's really cool to get to learn all of that stuff too. I never knew, you know, that I would someday be like opening computers and changing out RAM and, you know, installing new fans and stuff. So I'm learning all of that. I never opened a computer in my life, so now I know where things are inside there.
Just to give everybody a bit of perspective, the Adler Planetarium, where I used to work and where Maria used to volunteer, each task she mentioned, there were either like people whose full-time job was just that, or departments whose full-time job was just that. Coding up shows, we had a person doing that. We had a whole team just devoted to writing shows, a ton of performers to perform in the shows, show operators to run the shows, like, and that was just the theaters department. Like, maintenance was a whole nother department. So that is incredibly impressive that you can do all that. So not only do you run a planetarium as a staff of one, you balance your research in solar physics and all of the classes you teach as a professor. Do you sleep?
Mm-mm. During the semester, no. I mean, I tell the students, hey, I know you all are working hard for me. I am working hard for you. And they know that I'm up to all hours of the night doing things and preparing stuff. But I will tell you that especially this past year, the pandemic, and I am no longer, a 19-year-old college student, that it really took a toll on me. The staying up late and getting up early to get things done, it was not sustainable, and it can't be sustainable for the future. So this year, I'm going to have to put myself on some restricted bedtime and make sure I take time off and practice self-care, because it was just crazy. And I have to be a little bit better at my time management skills. And that's something that I'm still learning even now, so many years later.
One thing our culture does is kind of glorify, I guess, burnout and just working all the time. And I think it's very difficult to prioritize yourself and self-care. So I think that's really awesome. If you burn out, someone's got to run the planetarium.
Exactly.
Let's talk about the Wiley Planetarium's content.
I don't have a particular date yet, but we will have some public programming in the fall semester. And in particular, we have the launch of the James Webb Space Telescope that's supposed to be happening this fall. And our planetarium was selected as one of a few places around the United States, a couple, I'd say about 100 or so, that is an official NASA launch site party or public event. And so we'll be having one of those at the end of October. The James Webb at the moment was supposed to launch maybe early November. So we'll see, because that date keeps on changing.
Speaking of that, off the record, except this is going to be recorded, so I'm totally leaving it in. Do you think the James Webb Space Telescope will actually be launched on time or ever?
I don't, it's just been pushed back so long, so much money has gone into it. It's got to eventually launch. But now, the problem is the launch site, which is in French Guiana, they have COVID restrictions as well. And so it's a lot now having to deal with, we've got the science in place. Telescope is, I think, mostly ready to go, but it's coordinating that launch site, and because we're not launching it in the US, we're launching it from somewhere else. So that's when you have to rely on that and dealing with COVID at the moment, I'm not going to place any bets on it. But we're still going to have our celebratory launch party at the end of October for James Webb.
As much as we all in the science community like to sass the James Webb Telescope, as much as it's been a running gag for almost a decade now, I think, we all are very excited about its launch. The things it's going to see are going to be so exciting. This is very much we don't want to get our own hopes up, but when it launches, it's going to be so cool.
Yes, that will be a special day for all astronomers. And if I don't have to teach that day, I'll probably be glued to the television and just praying that it all goes well. No, Hubble has had some problems recently, and maybe it will get back up and running again. But, James Webb is, well, it won't ever replace the Hubble, but it's our next big telescope. And, with the uncertainty of Hubble and how much longer it's going to last, this launch of the James Webb can't come soon enough.
I don't like to think of it as a replacement. I like to think of it as the Hubble had a very good long career, and now it's going to be retiring. And
yes, it's not, I guess it's not a replacement, but because it will be able to see different things that the Hubble couldn't do. But it's the next big telescope that hopefully will be around for another 20 to 30 years.
In addition to the James Webb Telescope launch party, can you tell us anything about the shows or other events that people can expect from the Wiley Planetarium when you open in the fall?
Our shows are kind of a 2-for-1. You'll come for an hour, and the first part of it, I show you what the sky looks like tonight and help you get familiar with the night sky so you can identify the planets and the constellations. And I'll talk about some of the cool things that are happening in the sky that month. And if we have cool new science discoveries, I'll talk about that. And then we watch one of the, from our library of planetarium films. We have a lot of really cool films, everything from comets to planets to exploring the most energetic events in the universe. And we have some children's programming as well. And those are all different. I try to not repeat the shows too many times during the semester. So every show will be unique in some way.
Wow, that's awesome. So, for those of us who don't live in the area and can't come to the Wiley Planetarium in person, are there any virtual events or virtual content we can check out?
Well, we just had an upgrade to our planetarium, which will allow us to stream live, but that capability is still being worked out with all the kinks and everything. So I can't tell you an exact date of when we'll be able to stream our shows virtually, but that is something that we can do, and that is something that we're going to be working toward this semester.
So, it'll probably happen before the James Webb launches.
I hope so. I guess I hope to get it figured out before then.
So, everybody, go check out the Wiley Planetarium. I will link the website in the description. Look out for those virtual events too. Once those are up and running, I will add a link to those specifically in the description as well. So, if you're watching this weeks after it comes out, they might already be out there. So, let's transition to talking about you more personally. So, why did you decide to pursue solar physics as a research topic? I mean, aside from the obvious reasons to pursue the sun, I mean, look at those coronal mass ejections.
Well, when I was in undergrad, I just didn't know what sort of physics I wanted to do. I love like learning how things work, but like, how could I apply physics to an object or a thing or a system? And one summer I did a biophysics project, and I learned that I'm not very good in the lab. So I break things and I forget to turn this on and off. So I was like, okay. The next summer I applied for research positions, and I got one at an observatory. It was the National Solar Observatory, which at that time, the location I went to was in New Mexico, and a little town called Sunspot, New Mexico, on top of a mountain with a telescope to study the sun. And so I went there for 2 summers and did research and learned about solar physics. Actually, before that time, I didn't know anything about the sun other than what I learned in my astronomy class in college. So I went there and I learned about the sun. I was introduced to computer programming, and the work that I did was all programming and theoretical, and that got me excited about the sun and doing computer simulations and just entering into the world of solar physics. So when I went to grad school, that was something that I also latched onto. So it was kind of a lucky thing that I got that opportunity when I was young, because I didn't really know that it was going to be the sun. That opportunity could have been about a galaxy or exoplanets, although exoplanet research wasn't really that much of a thing when I was an undergrad, definitely much more now. So it was that really lucky experience that I had.
I think it's awesome that you were able to try out 2 different things, especially since most people don't find the thing they're good at the first time. And I think it's very important that people know, like, you can go try something out and it doesn't always work out. Not everyone is good in the lab. Not everyone's good in theory. You just have to find what fits. And if you like something, but you're not good at one specific application of it, that's okay. We talked to an archaeologist on this channel recently who talked about how there are a million different ways you can go into archaeology. You just have to find what you're good at and how that connects.
Yeah, and when I talk to undergrads or high school students who are interested in astronomy, a lot of times they have a very specific idea of a certain thing they want to study. And I'm like, well, don't limit yourself right now. There are so many things you can study. You could also be an engineer and be in astronomy. So don't get yourself kind of tunnel vision too early. Sample a lot of things, and it's good to it's good to also know a little bit about a lot as well, so that you could be more diverse.
In addition to your research, you're also incredibly involved in science communication. And that didn't start with you directing the Wiley Planetarium. Before that, you volunteered at the Adler Space Visualization Lab, where you taught my mom a lot about science when she
cool.
visited. Yeah, I still remember that. She got really excited. She's like, do you know Maria? I met this woman named Maria, and she taught me all about space and the sun.
That's awesome.
Yeah. You also participated in Soapbox Science Chicago, for which you recruited my wife, as if she needed another soapbox. I am also very passionate about science communication, obviously, but why are you personally so passionate about science communication?
I love seeing people get excited about science because, like little kids, it's not hard to get them excited about science, but they sometimes reach an age where they're unimpressed by these things, or they start putting up a wall where they think science is too hard, it's not for me. And if you can just show people that science is accessible to everybody and it's cool and it's okay if you don't understand it like, an expert with someone who has a PhD, you can still understand science and get a very good grasp of what's going on. And I just love seeing people just realize that the world around them, there's so much more than what they see on the surface. So for me, it's that feeling that I get. So maybe it's a little bit selfish, but it's a feeling that I get that, people are just so excited, and that makes me excited. And I just feed on that excitement. So that's part of it for me. But well, I'm down here in Mississippi, and there's a gap in a lot of STEM education. And so bringing people into the planetarium is one way that I can help the local school districts to provide the students with more content than they would get otherwise. And once you open everybody's eyes to what's there, like the science that's hidden, I think that maybe they start becoming more curious. I really love that feeling too, when people get curious about something that you told them about, and then they go home and like research more on their own. That's really cool. So another part of it is just to get people thinking about what's going on and to get them curious and asking questions and like doing their own research whenever they go home.
I love that you talk about accessibility because it's so important. Like, I am very much of the opinion that all people, even those without access to an extensive and expensive educational background, or people not in certain school districts, I think everyone deserves to learn about new scientific discoveries and have their curiosity rewarded. Like, I don't think you should have to be really good at math or know all of the background things. I think it's so important that as communicators, we are just able to frame it in easy to understand ways.
Yeah, I have met so many scientists who are like, my work is so complex and hard. I could never explain it to a person who is not also in this field. And I'm like, no, you can. You just have to be more creative about maybe the words that you use. It has nothing to do with like, how smart do you think you are? You might not know the vocabulary that we use to talk about space. So if you can use different vocabulary, different words, different phrasings to explain something, still it can be a high concept idea, but you're explaining it in different words that those people just, they haven't had the opportunity to learn yet. And I think that is something that a lot of scientists are not aware of.
Yeah. And another way to look at it is that the taxpayers, so average Americans, fund all of those science grants. So they're your boss and they deserve to know what they're paying for. And everyone in a career field has had to explain to their boss in words their boss understands what they do and why it's important. It also doesn't hurt that learning about the cool science that they're paying for makes taxpayers more likely to vote to fund more cool science. Part of the science community's job is to share that science, because what good is it if people don't know about it?
Yeah, and another part of it, most people don't think about government policy, but in science, we think about it a little bit because that's how we can get a lot of our funding, especially when we're talking about the sun, the space weather policy, and getting Congress behind that idea and get the public aware of this idea so that they are aware of that whenever it comes up in Congress. They could tell their local congressperson that they're concerned about these issues too.
The common refrain that's used right now during the current apocalypse is that scientists develop vaccines and science communicators convince people to get vaccinated. I think one that would work for your field is scientists determined that a solar storm could take out all GPS, all communication, and cause another apocalypse. Science communicators are the ones who convince people to call their Congress people to implement legislation to avoid it. So, yeah. Scientists can predict and solve an apocalypse. Science communicators get people to actually avoid the apocalypse.
Yes, that's a very important step.
Yeah. Do you have any specific advice for people who want to become astronomers or study physics, maybe high school and early college students who are looking at pursuing that as a career path?
Definitely. So if you're really interested in physics, of course, you have to keep up your math skills. So take as many math courses as you can to prepare you for the math you will inevitably encounter in college and grad school. Same for if you're interested in astronomy, although the requirements for astronomy with the math is not as strict. That depends on what type of astronomy or astrophysics you want to do. But it's definitely okay if you feel like you're not the best at math, you can still be an astronomer. So that's definitely a possibility. But another thing is to think about taking programming courses, computer programming courses, because we in astronomy have so much data. All of our telescopes are giving us so much data, more data than we can deal with. And humans are computers. They were the original computer. But if you can write a code to sort through that vast amounts of data for you, you can make your job easier and more efficient. So that's the part of data science, and that's the way of all this big data that really is important, especially in astronomy. So if you are really interested in being an astronomer and you want to discover new planets and new supernova, you should become proficient in programming. So the sooner you can get involved in that, the better. Computer programming is really awesome. I didn't learn about it until I was in college. I wish I would have learned it in high school or younger. My nephew, who's 10, is learning how to code. So there's a lot of possibilities, and it's a lot of fun. There are ways that it can be really fun, and it can definitely make your life more efficient if you use it correctly. So those are my pieces of advice. And of course, it doesn't hurt to try to reach out if you know somebody in your local community. If you're in a small community like where I grew up, there were no scientists around in a town of 1,000 people in the middle of nowhere, Indiana. So I didn't get to meet another scientist until I went to college. But you can contact astronomers on Twitter, on Instagram. You can get in contact with them, physicists, and just find out from them what it's like to be an astronomer or a physicist. And the earlier you do that, the better for any career you're interested in, so that you can see what it's going to take and what possibilities are for you.
Yeah, so high school students, math, computer programming, cyber stalking scientists.
Yeah, especially on Twitter. A lot of us on Twitter are more than happy to reply.
I've actually found that a lot of scientists recommend Twitter as the place to find them, which is interesting because a lot of people think of Twitter as the place for journalists, politicians, and also fascists. But scientists are there too. And you can actually learn so much cool new science from science Twitter.
Yeah, a lot of people live tweet what's going on at scientific conferences. So every year we have our astronomy conference in the winter and the summer. You could follow along with those tweets if you wanted to learn about the latest discoveries.
In addition to following Twitter, for people who aren't necessarily super passionate about math or programming, or who have just discovered their calling is something completely different, but who still want to casually learn about astronomy because space is really awesome, what would you recommend as a first step, or dipping their toes in, or just places to learn about astronomy in a very accessible way?
Well, there are so many awesome YouTube channels out there, like this one, that will teach you about scientific concepts. Neil deGrasse Tyson has a bunch of YouTube videos. I go to YouTube, honestly, to learn about things, or I read articles from like Sky and Telescope and space.com. Astrobytes is a really great place where you can go and they'll sort of summarize long scientific journal papers with the latest discoveries into a few paragraphs that humans can understand. And also you could go and play around with your own telescope or binoculars, actually. You can use a pair of binoculars to look at the moon, for example. And you don't need any fancy equipment really if you want to, enjoy the moon and our planets as well.
You actually have your own YouTube channel where you have all of your lectures online for free. Could you tell us where to find you on YouTube? And I'll put a link in the description.
Well, my channel doesn't have a special name. It's just Maria Weber's YouTube channel. I never thought that I would be putting all of my lectures on YouTube. But, when the pandemic happened, that's what I had to do. And so I have a bunch of playlists on there. My full set of lectures for my Physics for the Life Science class is there, and the lab class, and also my astronomy class. My full set of lectures are there. And I also have some short science communication videos that I put out for the Wiley Planetarium that are on my YouTube channel as well, with different playlists. But I'll give you the link so that you can check it out. If you ever wanted to take a full astronomy course or brush up on your physics, you can do that with these what I call mini lectures. They're usually about 20 minutes or shorter.
That's amazing. I love when education is free. That is the best kind of education.
Yeah, I was going to make it. I want my students to be able to get it easily from wherever they are. And if it helps other people too. I see I'm getting a lot of hits this summer for students taking summer courses. So students who aren't mine are learning as well.
That's so good. Thank you so much to Dr. Maria Weber for stopping by and teaching us all about the sun and chatting with us about science communication. Everybody be sure to check out the Wiley Planetarium's website in the description. If you're at all interested in learning a bit of physics and you want a series of lectures taught by her, please check out her channel. I will also put that in the description. Check out Soapbox Science. And remember to write your congressperson about getting electrical grids protected from solar storms. Like, actually, that's a thing. We need to prevent the next apocalypse.
Very important. Mm-hmm.
Seriously. Thank you so much, Maria. And it was so good to see you.
Yes, you too. It was a pleasure. And I'm so happy that I could do this. And I can't wait to see the finished product.
Yeah. Okay. I will see you another time.
Astra, to the stars, to the stars.